So new Panamax is already covered there. So new lock limit compared to Suez Canal. So there's a Suezmax size also, Panamax and Suezmax. New Panamax, this is a new Panamax size, so very big, probably 12,000 TEU or something. And the size of water is a dimension of the waterway is breadth is 49 meter, depth of the water is 15.2 meter for the new Panamax, the new Panama Canal. And this is items we should cover in system-based design steps. Right? That's transport task and function description, cargo spaces, crew, technical facilities, and summary, lightweight, and building cost, and main dimension, and general arrangement. This is a mission description for a 3,000 TEU container vessel. Right. So it's just an example. Right? So 3,000, the project name and mission description. The operation area is worldwide. Description is a regular, means liner shipping. Right? And year-round liner service. And target market is container transport. Payload, cargo capacity is 3,000. Endurance, what do you mean by endurance? So how many fuel oil should be in the ship when it's full, right? So for your car, when you fill up your gas tank, how many kilometers it can run, depending on the ship car size, right? So there is the endurance. You should have a tank size designed. So there is the endurance. 40 days without bunkering, the ship can run. And with that bunkering, you can have the same property, but with a different unit, right? Because there's speed multiplied 2 days, then you can have a 20,000 nautical miles. It's difference. Do you know what is a nautical mile? This is different from land mile and also kilometer, right? Land mile and nautical mile is different. You should know that. And then trial speed is 24 knot. This is not kilometer, knot. And what is trial speed? What is trial speed? Somebody knows about this?
Stationary.
Trials.
Stationary.
Stationary? How can you measure them? Car you can measure by rolling the drum, something, right? But for the ship, you cannot do that. Right? How can you measure the speed? What is trial speed? So there's a service speed, design speed, maximum speed. There are so many speed for the ship. For the car also, right? But trial speed, there is a, when you finish up your building, constructing the ship, there is a contract between owner and builder, right? So the ship should be this kind of properties and characteristics. One of them is speed, most important thing. One of the most important items is speed, right? So they should measure. So there is in the contract there is a specification. How do we measure this speed? So whether this is good or not. If the speed is not enough, then the builder should reconstruct or can have a penalty or depending on situation. Right? So that is a trial voyage, trial learning is done under the presence of owner toward the end of the ship delivery, near the delivery. So the owner or contractor is satisfied with all the items. There is also a booklet. We should test this kind of items in the specification or in the contract. Right? One of the most important items is speed. But there is other things. Checklist. So there is a condition. in this condition, we should learn the car, the ship, and then we measure the speed. If the speed is above 24 knots, higher is okay, right? Higher is okay for the owner, right? So it's higher than 24 knots. Okay, the checklist goes green light, right? So there is a trial voyage contract, and then we measure several things in trial voyage. It takes several days or more than a week, together with the owners and classification society and many other persons on the ship. And then if the trial voyage succeed, then we finalize the project, and delivery and payment is done. Okay. And then machinery and rough power demand. So machinery type is a slow speed diesel engine, fixed pitch propeller. Anybody knows about what is this means? First is slow speed diesel engine. Slow speed diesel. Yes? Go ahead.
It's a powerful engine.
Powerful. Anybody else? Anybody else? Speed. What is the speed? Slow speed, right? Slow speed. What is the speed? This is the RPM. RPM of the engine. Diesel engine. Diesel engine. Do you know what is diesel engine, right? Bus and there's cars are diesel engine. But speed of the RPM on your car, there is a RPM gauge. 2,000, 3,000, 4,000, right? There's RPM. There's the speed of the engine, right? Slow speed diesel engine, it means the RPM is around 100. What is RPM? Minutes. 1 minute, 100 rotation. But usually our car is running around 2,000 RPM, 3,000 RPM, right? My car. So 100 is very low, right? The diesel engine. So slow speed, but there is also medium speed diesel engine and high speed diesel engine on the ship too, but the size is bigger.
So the torque is higher. Is it a high power engine?
Right.
So the torque.
So how do you measure the power of the engine? How the unit of measuring power? What is the unit?
Watt.
What for engine? Anybody have an idea? What is the power of your car? Who has a car? Horsepower. Horsepower is the unit, right? Horsepower. Probably my car is around tens of horsepower. 100? 10? Around. I don't know. The ships, they are around 50,000 horsepower. 50,000. Depending on the ship size. And then the size of the engine itself. The high speed diesel engine, same power. Slow speed diesel engine, same power. Which one is bigger? The size of the engine. Same power.
So fast.
No. The torque will be higher. The torque will be higher.
Torque.
Torque.
No, okay, but torque, the same power. That should be same torque at the end, right? Same power, same torque at the end. But slow speed diesel engine, high speed diesel engine, which the size of the engine, which one will be bigger? Slow speed engine is bigger. See? High speed, low, multiplication, right? Same power. Right. So gas turbine, the airplane has a gas turbine, right? Their RPM is very high, so that the engine is very small, lighter. Because airplane should have a smaller engine, lighter engine, right? But power should be big. So they adapt gas turbine because gas turbine is very high speed, RPM, smaller size. Right? But ship is okay. Big engine is okay. Why we take a slow speed diesel engine in ship, even though it is a big and heavy? Because the efficiency is high. And also they can take a low grade fuel, the cheaper fuel, right? Comparing to my car, gasoline is a high price, right? The slow speed diesel engine, they take a low grade fuel in oil, and they are very cheap, right? Fixed pitch propeller.
I don't have
Question.
It's just a propeller on one axle,
Mm.
and in some cases you can turn the propeller,
Right.
so the vessel can also do this instead of
That is on the rotating propeller. That is rotating.
Yeah.
Propeller direction should be rotating.
Yeah.
But fixed pitch is different.
Okay.
The rotating propeller, the propeller position is rotating, so the propeller is in this way, so that we can change directions. Right? In the small motorboat, you can move the direction of propeller by hand. Right? There is a rotating propeller, but pitch is different. What is pitch? Pitch. From say bolt and nut, there is a pitch, right? How many pitch is one rotation? How many advance? Right? Pitch is one rotation, 1 millimeter or half millimeter. There is a pitch. The angle of what is it? Curved surface in bolt or nut. There's a pitch. Same, propellers are rotating and then pushing the water, right? Or air. So they have a pitch, one rotation, some advance, right? So that they push. There's a pitch. So pitch is fixed pitch. But sometimes there is a propeller which can rotate the blade, not the whole unit. Rotate the blade. We have a 3 or 4 blade, but each can be rotated so that they can change pitch. Pitch is the angle of the what is that? Surface, right? So by rotating, we can change the pitch so that one rotation gives more advance or less advance. So we call this is controllable pitch propeller comparing to the fixed pitch. Auxiliary power is for a small engine, still engine, but smaller engine, small power for electricity generation. Shaft generator, there is no shaft generator. Rules and regulation, what class? DMV. DMV is a Norway. That Norske Veritas, right? For Korean is KR, Korea Register of Shipping. Where is the Netherlands? NL. Where's the full name? Netherlands, what?
It's yeah.
Just an NL, right?
Netherlands.
America ABS, American Bureau of Shipping. Right? Lloyd is a UK. The classification society name. Each nation has one. So this is a flag of Norway, and so that they have a classification society of DNV. Crew is 20 persons. Route Panama Canal, right? Restriction to the main dimension. So you know that there should be the breadth is 32.2, less than that. Draft is what? Payload functions and ship function for container ships. Payload functions. What is a payload? Payload. What is payload? Payload. What is payload? Payload.
The money to the
Say like the cargo.
cargo.
Or per person. When you have a passenger carrier, I should pay myself, right? There is a fare, right? Per container, how much we pay for sending this one to United States. the pay money, right? Payload. There's a tons per tons. How much you should charge or pay? There's a payload. So tons. So cargo ships, the payload should be bigger, so that I can earn more money, right? I want to build a ship with more and more cargo space, so bigger TU, right? So it's important for designers. So payload function is important. Cargo space, cargo handling, cargo. That is a earning money size, right? And the other is supporting functions, right? So supporting structure is strong enough. Crews should have working efficiently, right? So we need a function for them, support them. Service facility, machinery should be strong enough. Comfort system, tank and boil. Tank should be fuel, water for drinking, shower, right? Outdoor decks. Right? These are supportive functions, but this is a main function, right? They can earn money, charge money, right? So payload is important for cargo ships. Number of crew on container vessel. You can see this is not linear function. This is not linear function. As the ship grows bigger, the crew number does not increase sharply, right? Tend to. So ton per TU, the crew number is down, right? So that is one reason for economy of scale. Right? Big ship, still we can manage with a small number of crews. Also, another important thing is automation, so that we can reduce number of crews. Right? Propulsion and machinery power, you can see that here is a TU, so it's a big ships here. And then propulsion power, megawatt or horsepower, right? Megawatt and horsepower you can convert by unit conversion. Auxiliary power, this is only for electricity generation, not for main propulsion. So there is small increase. But this is for main propulsion power. So the ship speed is range here, and range here, and range here. Right? So you can see that bigger ship has higher speed. It's easier in terms of a hydrodynamic point of view. For bigger ship can have easier to have a higher speed. Comparing to the small ship, it's very hard to get high speed for small ship. So there's a step functions of big ships and size and power. Power in trial and service. You know that what is trial speed and service speed is different, right? Service speed, in terms of service, it is dependent on the schedule. Service speed should be dependent on schedule and route, right? But nowadays, the conference means the teams of ships operating companies together as a conference, they have a same schedule. But several companies are joining the conference to make a regular service route scheduling, right? But because nowadays world economy is down, the cargo demand is down, so that they decide to slow down the ship. So the schedule can be changed and ship speed is down. So service speed is different from design speed and normal speed. Service speed is depending on the situation. You can choose. Because of there's coming a storm is coming. So they should be escape, or they may be speed up, or maybe slow down, depending on the situation. So service speed is different.
But who decides the speed? I mean, the customer maybe, even though the economy is not good, but they want get their product
Right.
as soon as possible.
Right. Customer needs a faster delivery, right?
But the ship company,
Mm.
the shipping company, they want to delay the
Right,
the,
right,
the delivery.
right.
So who decides
Right.
the speed?
Right. For the liner shipping, they should keep the schedule. So that is determined already. But whole company who is running in that schedule, because one schedule cannot be operated by one company. It is, so I call this is a conference. One conference between, say, Los Angeles and Busan and Kobe, Shanghai can be a one conference. Several companies are joining together to make a schedule. So they should decide on schedule if you want to change the schedule. Otherwise, one company cannot change the schedule. Then whole conference can have a problem, right? So this is a complicated problem to deciding on speed, right? In a liner shipping. But in another case, you can choose. Say I'm a oil company, SK Energy. I have my ship. I want to bring my crude oil from Saudi Arabia. So I can decide when to bring that oil and how fast it should be. I can decide. So the company may decide on schedule. But in the local way, the captain should decide. Because there's storm is coming, he can make some small adjustment depending on local time. But same as high express bus driver, right?
Yeah.
He has a requirement to arrive at some time, right, to the Seoul. But in local time, there can be a slow down or speed up. Anyway, trial is there's a contract so that we should have this speed at this amount of power, and this is a maximum continuous rating. This is for engine power, right? My engine, I can have a full acceleration. RPM can be 8,000, and then power can be higher, right? So it is maximum continuous rating. Maybe my car break down if I push 8,000 RPM for 1 hour, right? So MCR, there should be some limit, right? Designed condition, 80% of this. So the trial condition should be check. I want to check the engine test. So we should have a full power at the trial condition to check whether engine is okay, right? And then we measure this speed. But in normal service hours, they do not use full powers. It depends on situation, but usually they use 80% power to increase the lifetime of the engine. And then speed may be in this way. And also why this curve have a difference? Because we have a cargo on there. But in trial condition, we don't have a cargo there. Empty ship, usually, right? New ship, no cargo, right? So it's a lighter, so that less power is required. So conditions are changing. Lightweight and deadweight main groups. Lightweight is myself. When ship is delivered, new ships, it's lightweight. Then deadweight is a cargo weight. So we can sum together to make a whole displacement. We call displacement. So you can. There's some more fine details, but you can say that there is already there. So this is whole displacement. So what is the displacement? What is displacement?
Total weight, because the displacement should be same with total
Right.
weight.
What is the displacement itself?
The ship displace underwater.
Right. When I'm pushing down, say using some big ball or or big bowl, any shape, if I pushing down them into the water, I should use force, right? And then I'm pushing down the water itself. We remove water, right? There is a displaced water. That gives you the tone. So how much water the ship is displacing, pushing down. There is a displacement. That is the whole weight of the ship. The same as whole ship. Right? When I putting this ball on the water, there should be some line here, right? So that is depending on this weight of this one. So when I push the water, displaced water should be same as the weight, total weight. And total weight is made of ship itself and cargo weight. So together it can be a whole total weight. Question? Lightweight calculation is not easy, but we usually have a statistics. So we can have many previous ships, so that the power, based on power, this is a megawatt, what is it? This should be million something ton, I guess. And then per installed power, ton per kilowatt. This is easier, right? Ton. So weight, power, ratio. So tanker is say higher ton per power. So it should be slow ship, right? Tanker, the oil tanker. Higher ton per same power. What is it? Ferry and Ro-Ro? What is Ro-Ro?
Passenger carrier.
Passenger car. Ro-Ro. Ro-Ro means a roll on, roll off ship. Something which can roll on, roll off. So the car carrier or truck carrier, there's a Ro-Ro ships. Or train carrier too. Train carrier, right? The cargoes can roll on, roll off. Is a Ro-Ro ship. Okay? Ferry is similar, but ferry includes also passenger too. Ferry is small size. Ro-Ro ship is only for cargoes, but special cargoes, rolling cargoes. But ferry similar to Ro-Ro, but includes also passenger together. So they are less ton per power. So it can be high-speed ships. Comparing tanker. And what is this? Ton per area. Ton per area. So passenger ship, the size, and cargo ships, and different. And building cost distribution, the material cost, and labor cost. This is most important items. Material means steel, engine, and all the materials. Kitchen, piping, crane, all the materials, right? So this is the basic ship itself, all the material cost to build the ship, right? And then all the men salaries of the whole shipbuilding company. And then it comes with the design cost is separated out because sometimes it can be outsourcing of design. Somebody else is making a design. Building time financing. What is building time financing? They loan money. The company loans money to build the ship, to purchase material, to pay salary. Because there is the money payment is not continuous. There is several steps of payment. Right? From the beginning, probably there is some money, down payment. But at the middle way, probably twice or three times payment. In the middle, depending on the situation, usually they should use more money than income. Because the final one should be at the delivery state. the whole ship should be completed and checklist should be okay, then final payment is coming, right? So before then, I should pay more. The shipyard say pay more because completed ship is already there. But money is still not coming, right? Final money is not coming. So there should be some loan. So there is some financing money there. The interest rate. Ship loan financing. What is the ship loan financing? I don't know what is this one. I should check this one. Probably this is complicated. Brokers, there is a brokers there who is broking is matchmaking the buyers and constructors, right? Matchmaking. And profit is shipbuilder should have a profit there. And building cost estimation, we see that this is the estimation. Because the money, the exact money should be known after delivery. Probably after some time after delivery, right? Probably several months after delivery, right? Because it takes long time to calculate. But anyway, we need to have a contract signed with some fixed money. So we should have an estimate at the beginning. Say you can assume that you want to build your home, but there should be a contract with the builder, right? You should decide on the money, how much money you should, with this drawing something. I have a wish sheet to build this kind of house. How much money I should pay? There's a contract signed. So we need to have an estimation at the beginning, before the contract. So it's not easy, right? It's not easy. Very complex calculations, right? So payload, hull structure, deck housing, this is a weight groups, machinery, outfitting, and design fee, labor, material, summation, and then profit, financing, brokerage, something. Main dimension for container vessels. This is a TEU. Container ships. Panamax is around here. And this is a new Panamax. And post-Panamax is around here. Post-Panamax. And this is breadth, right? There is one clear line that Panamax is there. 32.2. Many ships are along this line, right? This is Panamax. So below them, they can pass through the Panama Canal. Above them, they cannot. So there is a jump, right? Post-Panamax, there is a jump. And then it keeps going on. There should be another new line around here, right? The new Panama Canal is opening in the future. Recommended hull form coefficient. Block coefficient, prismatic coefficient, water plane coefficient, midship coefficient. There are shape and coefficient to measure the slenderness, fullness of the ship. The most important one is CB. And fluid number is measuring the speed of the ship. High fluid number means high speed ship. And you can see that the block coefficient should be lower for high-speed ship. Okay. Fluid number, block coefficient is going down. Okay. So crude oil tanker, they don't need to have a high speed. They want to bring more and more oil. So they are full, slow and full. They have a high CB around 0.8. Around there. But ferry and destroyer, warship, CB is around, CB around 0.5 or less. So this is a design summary. Once again, mission description, operation area, worldwide, regular liner service, then cargo, 3,000 TEU, but this is divided inside the hold above deck, we have a more containers in the hold, less on the deck. Crew endurance is same as before. Length overall and length PP you explained last time. Breadth, depth, draft explained this one, right? And then gross tonnage, dead weight. There's several tones, gross volume, cargo space, displacement here also there. This is total weight displacement. Displacement is made of what? Lightweight and dead weight. Right? So dead weight is here. But in terms of tone, in terms of TU. But this number is wrong. I guess it should be higher. Probably 11,000, and so there should be one more zero there. Machinery, slow speed diesel engine, fixed pitch propeller, propulsion power is 3,000, 35,000. Number of propeller, right? Delivery time and building costs. This is important for shipbuilders, right? Finally, right? Building price. Norway krone. Right. Bulk carriers. Right. Can be short. Let me see. So dry bulk carrier ship types. What is a wet bulk carrier? Wet bulk carrier. Oil. Right. Tanker is a wet bulk carrier. Right. Dry bulk. Seaborne trade and something. So this is a graph for unloading bulk cargoes. It looks like a grain something, grain. But it can be a core, can be a ore, any kind of things we can be spread out, right? But it looks like a grain. But bucket, when you see that in the ground structure, they are digging soil, bucket is used, right? The same one, but different style, bigger. That's the dry bulk carrier. Sloped wing tank. This is sloped wing tank. Upper wing tank, right? Wing tank. This is sloped wing tank. This is shape specialized for dry bulk carrier. If you see, when you have a experience on design, when you see the mid section, you know that which type of ship is this, right? You know the container ship shape, right? Midship with open hatch and high tier of containers stacking inside and over, right? No such one. There has been only wider side tanks. Yeah?
What is the purpose of the?
Why the purpose? Right. It's a grain, right? Grain is pouring, so shape usually comes in this way, right? Pouring. Also, when they have a rolling of ship, the shape is going this way. The most important thing is when you have a, say, this shape, this is very hard to filling up in this corner.
Shaking.
But shaking, well, easier shaking, right? So that's a natural way to keep that space filled up, right? Also, there is another reason, but because of that grain or dry bulk property, is naturally comes with this, right? Okay, and there is a hatch cover. We need to have a grab put inside here, right? Going down, such as this one. This is inside cargo hold, right? So above that there is a hatch cover, hatch opening, and then grab is coming into the cargo hold and catch grab. So there is some size of hatch opening there. Enough size of hatch opening.
Why the bottom part is also sloped?
Oh yes, it's the same reason. The grain is sloping down. When you finish up, it's not easy. If the ship is in this way, it's not easy to grab this corner grains. You should have a person should collect, right? So with this one, it's easier to collect.
Is it impossible to use like vacuum?
Oh yes, you can do that. You can do that. Especially there is already, right?
So if they use, okay.
Still with vacuum, the corner is not easy, right? Have you done your vacuum cleaner in your home?
Yeah.
It is not easy making a corner vacuum cleaning, right? So they make such a shape naturally. Any other questions? Those are types, ore, right? Steel making ore. But there are combinations, ore and oil. Why in this way? Because of the location of producer and demander, right? One country produce ore, one country produce oil, they can exchange. So that in this way ore, in this way oil, something like that, depending on situation. Yeah. And bulk oil, grain oil, forest
Why
product.
it is dry volcano? Because you said oil is wet.
Right.
So
You're right. Still there is a ore there. Specialized dry bulk. Right. Forest product. Paper wrap or roll. Converted tankers. They convert bulk carrier into tanker or tanker into bulk carrier. Conversion. Sometimes it requires. Onassis, do you know who is Onassis? Who is a famous shipping or ship owner who married with Jacqueline Kennedy. Jacqueline Kennedy, do you know who is Jacqueline Kennedy? Right. After John F. Kennedy died, she married with another rich man. There is Onassis. He has been a ship owner of Greek. He born in Greek because Greece is very famous in shipping and ship owning business. He in 1950, around 1950, when World War II is finished, all the military ships, they don't need to have such a big ships. So United States sells the big cargo ships, military cargo ships, very cheap money. But nobody want to buy because there is no demand, right? Onassis take many of the ships with the cheap money. But there is something coming. What is that? What battle between Egypt and Israel? So that the Suez Canal is closed. Saudi Arabia to Europe, Netherlands, no way. Suez Canal. They should go into Africa, South Africa, so that they need tens of more ships comparing to Suez Canal. Eh? 10 because longer distance. You get big money. It's ship all the ships. They convert into tankers at the time probably. Car bulk carrier, container, specialized bulk carrier, all-round bulk carrier, economy of scale. Iron ore, the steel making iron ore imported to Japan, share per ship size. Right? And the years from 60s, 70s, 90s, when the Japan grow fast, industrialized, right? So that the bigger ship takes more portion in the late stage, right? Big ship, bigger ships is coming, comparing to small ships in the beginning stage. There's the economy of scale. Bulk carrier economies of scale, right? Handy size, dead weight. This is cargo weight, right? Dead weight. Handymax, Panamax bulk carrier, not container ship, bulk carrier. Cape size. Cape Horn is Africa, South Africa, right? It's bigger, right? Panamax Capesize. Ultra Cape. See? But this deadweight is around the same as new Panamax with a 12,000 TEU ships. The back ships. Length. Breadth is much bigger. Direct something. Seaborne trade of a whole world dry bulk shipment. But biggest one is what? Coal. Is it right? Coal, or grain. Right? In 75 to 2005, million tons. Dry bulk cargo is growing fast. Coal market, oil market. Examples. Capesize. Bulk carrier with a 1,776,000 deadweight grandeur. Length, no, something wrong. Should be, this one is correct, so it can be 2. It can be 2. Breadth, depth, draft, deadweight, gross tonnage, power, maximum continuous rating, engine size, speed, service speed. You should know what it means, right? Once again, you know what? Length overall, length between perpendicular, right? Breadth, where's depth and draft? Depth and draft.
Depth is the highest, the structure's highest point and the lowest point.
And then draft, what is that? Draft?
Depth is C line.
Waterline, right? Waterline. Right. Here, there is a water somewhere here, right? Design draft, maximum design draft. You cannot load more cargo above that line, right? Because there is we call this is a freeboard. So, ship and some structure there. We call this is depth, not all. This is depth. Up to upper deck. We call this upper deck. Upper deck is something here, right? Upper deck. Upper deck. Here you can see the higher superstructure, but superstructure is only here. Only here, superstructure, right? So upper deck is this one. Up to upper deck, we call this the depth. And draft is around here, right? Draft is draft. D or T. Sometimes you use T, but usually small d, large D, draft. Right? Depth and draft. We call this is a freeboard. Freeboard. So depth is made of draft plus freeboard. Freeboard is requirement for the safety. Regulatory body, classification society, International Maritime Organization, they set up this ship should be have enough freeboard for safety, right? So that so it comes with depth minus freeboard should be draft.
So spelling is correct.
Oh, it's an old word. Old word. Nowadays we have a short name, draft, without UG, no UGH. Just no, F is there, right? But this is old English word something. Deadweight, gross tonnage. Gross tonnage is a little bit complicated one, but there is I will not explain this. Self-unloading, bulk carrier. What is self-unloading? He has a own way of loading, unloading cargo, the grain cargo. So you can see here's special shape here again, and below them there is a conveyor belt. There is an opening here, and then under that there is a conveyor belt, and the conveyor belt is coming from here to here, and then up into the boom. So the boom can rotating and delivering in this way grain down the port. So self-unloading bulk carrier. Good idea, right? Good idea. Automation of cargo unloading, right? From the port is okay because silo is a big tank silo. They have grain. They pouring down grain into the ship very fast, similar to water, but it's grain pouring down. But unloading is very complicated. Grabbing very slow. But self unloading is very nice, faster. But it can lose space there, the shape there, lose space. Also the cargo gear equipment has a power and money there. So depending on your situation, you can choose. There's an idea there. Any questions? Then we can go on, or right. Then short sea shipping. This is taught a little bit different topic, but coming again. Right? Short sea shipping. We explained about hub and spoke. Hub and spoke. This one is explained by Professor Akimoto the other day, right? Hub and spoke. Hub and spoke. Right? Hub and spoke. Oh, cycle. Cycle. Tire. Wheel. Right? This is a hub. This is spoke, right? Hub and spoke. The same idea in shipping. So short sea shipping means the spoke area, not hub area, hub line, the spoke. So European short sea shipping, and what can be an innovation in short sea shipping? Transport performance inside the EU region. So it only deals with short sea shipping. This means only short sea, not long distance between continents, not between continents, only inside Europe. Right? Then you can see that road is the biggest one. Road. The share of mode, right? Share of mode. Road is biggest, but second one is sea. Inside Europe. By tonnage, probably it's ton kilometer. You should careful about the measurement, right? Ton kilometer. And then it comes with a rail, and another one is inland waterway. So this is a sea, short sea, around Europe, and inland waterway is in the riverside, canal, river. Ara waterway. It's the lowest. But it is ton kilometer, not money. Not money is different, right? But ton kilometer is totally different. Money and ton kilometer is totally different. So usually you can say heavy and big amount cargoes goes through sea. But low price, with a low price. Heavy, big amount of cargoes goes through sea. That's why the number is, ton kilometer is higher. But it's in the low price. So not in terms of business, it is a different story. Right? Number of ships by deadweight class in short shipping. There's a number of ships. Well, I want to show you the types of ships used in there. Ro-ro, reefer is a refrigerator. Refrigerator. So icing, cold cargoes. Product tankers is a tanker. There is a crude oil tanker, product oil tanker. What is product oil tanker? Produced oil, processed oil, gasoline, chemicals, which is already separated out, processed, refined. Passenger rollers. This is a ferry, right? Similar to ferry. Passenger and roller together, we call it ferry. LNG, right? Liquefied petroleum gas carrier should be same category as product tankers. General cargo, the old style container carrier. Chemical oil, once again they separate out from product tankers. Oil, this is probably drinking oil, something, eating oil. I don't know, probably there. Chemicals, some special chemicals. Chemical tanker also. Cement tankers. There are many different types. Innovations in short sea shipping. Because the money investment is not so big comparing to ocean-going ships, they can have a more specialized, how can I say, you can use your good idea here. You can test, because the money is smaller, you can test your good idea here, not in big ships. Right? Big ships, the big investment tend to be less innovative. Right? Risky. Automated cargo handling, short sea shipping along the Swedish coastline, fast ship Atlantic ocean going, automated container handling, Sea River hatchless container, Sea River. This is Ara waterway, Sea River, right? To the China, we go to Sea, Yellow Sea, Han River, hatchless container ship. You can think about this one for your project. Sea River tugboat. This is another alternative, right? Tugboat car carrier. Forest product innovation and optimization. Short sea gas tankers. Several categories. This is a picture coming from an artist. It's a concept car or concept ship. Coming from Sweden. I don't know whether this ship is built or not. This is just proposal, drawings. Right? Looks like this is ice something. I don't know, or land, but it looks like very fancy. Right? And then it has some containers on the deck. Right? And there's heliport there. And I don't know what kind of cargo is inside. Probably Ro-Ro cargos, passenger cars or trucks. Oh, there's a general arrangement of this. The same ship. So heliport. The bottom tank plan. Tank plan means this elevation. The tank top elevation. In this, if you cut this line, the second line, you can get this drawing here. This is a shelter deck. Shelter deck is around somewhere here. Right? This deck, or this, probably this line. No, this line. Up to here. Okay. Length overall is 122. Length spreads. Deadweight service speed is 70 knots. Oh, here comes with a loading. It's the same ship. They are loading and unloading cargoes by special way. Looks like a conveyor belt something, right? And cargoes, containers, trucks moving in this way, and then moving automatically something. Anyway, this is an idea sketch of automated cargo unloading something. This is another ship, automated guided vehicle, AGV, cargo handling system, and looks like this is also automated one. Right? And on the rail, probably for the train or truck, was stacking 2 tiers and goes in line into the ship. But the back side of the ship, right? Back side of the ship, I can do that. But in our project called Mobile Harbor, we had a similar idea there with this one. You can check out. And this is another. The picture is not clear, but they are trying to automate the container handling for inland ships. There's a jet-like enclosed terminal. See, this is a ship. This is a ship. And containers sticking up. So this is a ship. Ship is inside here. This looks like a ship. But the terminal is bigger. This is terminal, right? This terminal with cranes there. The cargo is up and down into the ship. Ship is inside the terminal. This is very similar to B1 type mobile harbor. But we did not see this picture before. Right? Anyway, automated container handling enclosed terminal. And short sea car carrier. You should know that there's a ramp at each deck so that car can move up to this by himself. The drivers, they are very good expert driver. They paid by car parking per day or per hour, so they should be very fast and parking in exact short line, corner there. And anyway, see, because they carry say 1,000 cars, probably it takes a long time to loading and unloading. And tugboat car carrier. This is tugboat, and this is barge. Barge, it means there is no engine there. Barge means there is no engine. Tugboat usually pulling barges using rope. There is a usual way, but here they pushing barge. We call this a pusher barge. Pusher and barge. Pushing tugboat and barge. So there is a special shaped barge so that a pusher or tugboat can enter into and have a stronger unit there. North Sea Rhine car carrier. North Sea Rhine, probably in Germany something. Netherlands? Really? Okay. All done. Any questions?
Question.
Right.
So the barge car carrier is pulling barge or push barge. I don't know. But where-
This case is pushing. This is pushing. Pusher barge. Pulling, you should have a tugboat here and have a rope there and go in this way. Pulling the rope. There is a normal case, traditional way of tug and barge with a rope.
But how they change the direction in this situation?
Oh, the pusher can change direction. Same as a ship. One ship. Ship has a. If you can think of this is one single ship. There is one single propeller there. But tugboat should have a bigger propeller than himself, right? Bigger, and rudder is also big. Netherlands has a good skill on tugboat, and specialized ship is very good in Netherlands. Dredgers and.
Yeah, but they use this as well from the North Sea to Germany. They use this.
Questions? No. All right. And see you next time.